So let's take a problem with adding, subtracting, multiplying, and dividing to combine these functions. So let's take and add f plus g of x. Now if I'm adding these two together, I would like to express the answer in simplified form, and I would like to express it in standard form. That is, start with the highest exponent and work down to the constant. So if I'm adding these two together, I get x squared from the g of x. I'm getting 2x from the f of x, and then 4 plus 9 is 13. If I have f minus g of x, 2x plus 4 minus x squared plus 9. Now I put each one of them in parentheses because especially the second one, I want to make sure that I distribute that negative, and these are common mistakes that you see, that I see in grading. So I would have 2x plus 4, but then this would be a negative x squared, and it would be a negative 9. And that's a common mistake that people make. They just write minus x squared plus 9. And you really have to distribute that negative. So now in standard form, I have negative x squared plus 2x minus 5. Now don't multiply through by negative 1 and change all the signs because you think it would look better with a positive x squared. No, it is a negative x squared plus 2x minus 5. Don't change all of the signs. Let's take f times g, or f of x times g of x. This is two binomials, so I'm going to multiply them together by FOIL. So the first of each would give me 2x times x, or 2x cubed. The outside is positive 18x. The inside is positive 4x squared. And the last terms of each, 4 times 9 is 36. Now I still would like this in standard form, so I'm going to start with 2x to the third plus 4x squared plus 18x plus 36. The quotient, f divided by g of x, is the f function in the numerator, 2x plus 4, and the g of x in the denominator. Now you could factor 2 out of the numerator, but it's not going to help you because you don't have anything then that you can divide out as a common factor with the denominator. So just leave it this way. Okay, I'm going to start out with the function f of x equals 2x plus 1, linear equation, and g of x equals 2x squared minus 3, a quadratic equation. So now I have f of g of x. Now that's one notation with the circle. It's read f of g of x. Another way of representing it is f of g of x with that notation. Both of them mean to take the g function and put it into the f function and simplify. So the f function is 2 and then a parenthesis for x plus 1. That parenthesis I'm going to replace with the g function, 2x squared minus 3. And then I'm going to simplify. So I left that opening by putting a parenthesis there. So that's important because now I can use the distributive property and get 4x squared minus 6 plus 1, and simplifying, 4x squared minus 5. If I have g of f of x, another notation would be written this way, g of f of x, and now the f of x function goes into g. So now I'm going to leave an opening for x, so 2 times, and then in parenthesis, some quantity is going to be squared, minus 3. That quantity that's squared is 2x plus 1. So let's simplify this. Do not multiply through by 2 first. We're doing the power first and then multiplying by 2. So this is 2, and then I'm going to be taking 2x plus 1 times 2x plus 1, multiplying the result by 2, and then subtracting 3. So let's work on simplifying this problem. Inside the bracket, I have 2x times 2x is 4x squared. The outside is a positive 2x, and the inside is positive 2x. And 2x is 4x. And the last terms of each, 1 times 1 is 1. Multiplying through by 2, I'm getting 8x squared plus 8x plus 2 minus 3. So it's 8x squared plus 8x minus 1. And you'll notice that the result that we got for g of f of x is different than what we got for f of g of x, meaning that composition is not commutative. In other words, the order does matter. F of x is 2 over x minus 3, g of x is 8 over x plus 1. So again, I'm putting the g function into the f function. So 2 is in the numerator. In the denominator, in place of x, I'm putting 8 over x plus 1. And the rest of the denominator is minus 3. Now, in this fraction, let's rewrite it down here so I have a little bit more room. I want to get rid of the fraction within a fraction, and this is a problem that you had on the last quiz. In order to get rid of the fraction within a fraction, I need to look at all denominators of the fractions within a fraction. And we have a denominator of x plus 1. So I need to multiply the numerator by x plus 1 and the denominator by x plus 1. Because x plus 1 over x plus 1 is 1. I'm not changing the fraction in value. I'm just changing its representation, how it looks. In the numerator, I have 2 times x plus 1. In the denominator, 8 over x plus 1 is being multiplied by x plus 1 over 1. So the x plus 1's divide out, and we get 8. But then I still need to multiply x plus 1 times negative 3. So it's negative 3 times x plus 1. X plus 1 is distributed times each of these terms. And then to simplify. So I have 2. I'm going to, right now, just going to leave this 2 times x plus 1 over 8, and then distribute the negative 3. Negative 3x minus 3. Now, if I could factor the numerator and divide out with a common factor in the denominator, I would. But this is not going to be the case. So I might as well multiply this out and get 2x plus 2 in the numerator. 8 minus 3 is 5, minus 3x in the denominator. Nothing divides out. I can't divide out like terms I can only divide out like factors. Now I also want to take a look at a restriction on the denominator. 5 minus 3x cannot be equal to 0. So negative 3x cannot be equal to negative 5. X cannot equal 5/3. I want to put the f function into the g function. So I have 8 over, in place of x I'm going to be putting 2 over x minus 3 plus 1 in the denominator. Okay, I'm going to make this a little bit larger over here. Looking at the denominator of the fractions within a fraction, I want to multiply the numerator and denominator by the quantity x minus 3. So I'm putting it in parentheses. In the numerator, I have 8 times x minus 3. In the denominator, x minus 3 times 2 over x minus 3. The x minus 3 divides out, and I have 2. But then I still need to multiply x minus 3 times 1, which is just x minus 3. Now again, I'm not going to have anything that can commonly divide out as a factor of the numerator and denominator. So I have 8x minus 24 in the numerator, and I have x minus 1 in the denominator, of which x cannot equal positive 1 for division by 0.